$295 at Best Buy.
Hi, everybody, and welcome to the Pre-Accident Podcast. I'm your host, Todd Conklin. Well, here we go again, man. It's always fun to do these podcasts, and it's been a great week for me. Very excited. I'm really excited about today's podcast, actually. I can hardly wait to actually play it for you. That's how excited I am about the podcast and all of its excitement, because there's much greatness on this podcast. You only have to wait and listen. Today, we're going to talk to a guy named Adrian Cockcroft. And Adrian is a long-term computer back-end DevOps reliability guy. And he's worked everywhere. I mean, and he talks about it a ton. It's actually really fun to listen to this podcast. He does a bunch of work with highly reliable systems. And he contacted me, just sent me an email, and introduced an idea for a podcast that I couldn't really say no to. And you'll see why. In fact, I'm almost certain this podcast is going to be called Chaos Monkey. We'll see when I actually type out the stuff what comes out of there, but I think you're going to find this podcast to be very, very interesting. Adrian's going to talk about the fact that when we talk about failure, we're really talking about failure like it's a bad thing. But in fact, failure is how we test the margins of safety. And failure is what allow us to know if our systems are reliable enough. And so failure is not in and of itself bad. Catastrophic failure is awful, of course, but small failures actually lead to growth and strength and robustness. Now, Nassim Taleb called this anti-fragile systems, but Adrian calls it what he does for a living. And what he says is we have to be brave enough to know on the surface that we must test our systems for failure because we will have failure. And he makes a couple comments. I'm going to say them now, which is a little unlike me. I usually try to shut up before the podcast starts, and then I'll come back to it at the end, I'm sure. But he says you can't legislate against failure. You cannot comply yourself away from failure. And that you can't predict where the next failure is going to happen. So if you can't make rules against failure, and you can't predict where failure is going to happen, then you're pretty much stuck in the middle with figuring out how to use failure to actually make sure your systems are robust, mature, and effective. And to do that, you've got to flip your assumptions away from our system is perfect and will never fail, our job is to prevent events, to a much more enlightened view which says our system will never be perfect, our people will never be perfect, our processes will never be perfect, and failure is quite normal. And when that failure happens, do we have the ability to actually manage away from the negative consequence? And that is pretty much the new view of safety in a nutshell. I think, well, you tell me, but I think you'll listen to this podcast more than once. In fact, I can almost guarantee that you'll listen to this podcast a couple times because it is chock full, whatever that means. And I think it's more than just full. Full is full, but chock full is very full of enlightened information and just knowledge, just matter-of-fact knowledge. It's just a conversation. We're just talking, a couple guys talking, right? We're using Skype, so you can tell how good the talk's going to be. But we're going to talk about this idea of failure. Let me kind of back off from here and go back and say, listen to the podcast and see what you think. Other than that, I think things are grand here. The summer is in full swing, which is always nice. Scheduling is scheduling. I would talk about how bad I am at it, but I think that's getting tedious. Gosh, I'm trying to think if there's anything really exciting. The new book is doing really well. Thank you for picking up the Pre-Accident Investigation Better Question. I can't tell you how excited I am about you having that book and how excited I am about the potential for that book to sort of lead you into a different way to learn and engage your workers in really better investigations. And the way we get to better investigations is we ask better questions. So, but that's all coming up. That's coming up later. So until now, why don't you just sit back and relax, let your ear holes be filled with wisdom for about 20 minutes or so, and listen to Adrian Cockcroft. And he's going to talk to you about failure and his team of simian failure monkeys.
So my name's Adrian Cockcroft, and I've spent the last sort of 30, 40 years doing various things across the computing industry. There's a few things I wanted to talk about today, and one of the things that was inspiring me from listening to your podcast over the last year or so is you talk a lot about failures and how to avoid them. And one of the things that I've worked on is like deliberately inducing failures in order to discover what happens and make sure you actually do have the margin you think you have. So that was the topic I wanted to sort of talk about a bit.
Oh, tell us more. That's so interesting. In fact, what I love is what started this whole thing is you use the word chaos monkeys. And I'm curious what that all is about.
Yeah. So the Chaos Monkey idea came up from Netflix. It wasn't me that came up with the name, or the idea came out of some discussions we were having. So to give a bit more of an introduction to me, I currently work at a venture capital firm where I'm basically trying to figure out what's going to happen next in technology. Before that, I spent 7 years at Netflix. Several years of that, I was the chief architect at Netflix for the cloud transformation and how we were rebuilding the site to go from shipping DVDs to streaming globally.
Wow.
Yeah. So that's most of this sort of topic, and I will get back to some of that. So before that, I was at eBay, and my title there actually was Distinguished Availability Architect, which was an interesting sort of thing. We were trying to figure out how to stop eBay from going down because it costs a lot of money when it goes down. And I spent a long time at Sun Microsystems before that, where I was working on some of the big, really big machines they built and the software they built and monitoring tools and things like that for figuring out what had gone wrong and how to make reliable hardware, reliable software, and then reliable operations of those. So in that sense, I was working on how to make really big single machines mostly more reliable. And then at eBay, I learned much more about how to make thousands of machines working together act more reliably. They call that scale up and scale out. So you've got lots of replication that you can work with when you're doing scale out. And then when I was at Netflix, we worked on taking our existing system, which was a mixture of the two. We had one big back-end, huge database server, and if it went down, everything stopped. And in 2008, it did go down for a few days, and there was a big outage. We couldn't ship DVDs. And that outage caused us to rethink how we were operating ourselves. We wanted to move to something that was more flexible to support the streaming workload, but also something that was more reliable in aggregate. And that was when we started looking at this new cloud-based services that Amazon Web Services was bringing out at the time. So we figured out an architecture that fit with that, and that's where the whole idea of you're running on low-cost, relatively low-reliability machines, but you aggregate them together to create a much more reliable ensemble, if you like. That make sense?
Totally, yeah. I like how you talk about these complex systems and how you increase, using the complexity, the opportunity to fail in order to learn. Wow. That's incredibly interesting to me, and I think everyone else. Yeah,
so one of the people that helped build AWS when they first started it was a guy called Chris Pinkham. And I was talking to him at a conference. We were on stage talking about, we were like jointly presenting a sort of a panel session. And he said something that really kind of distilled this for me. He said you can't legislate against failure, right? You can't have a law that says this won't fail, but what you can do, and you can't say what will go wrong next, but what he said was that he always focused on being able to detect quickly and respond quickly. And almost all of his engineering investment was around detection and response, rather than trying to make any particular part of the system sort of, because it's always going to fail in the thing you haven't looked at yet. Right, next.
Right, absolutely, totally, completely get that.
Yeah, so that was a key thing. And then what we'd done at this sort of Chaos Monkey idea was that you've got a running system. At various times, these machines will disappear. AWS at the time was running on very low-cost commodity hardware, and they had machines just disappear. They would just stop working, and one of your servers would just not be there anymore. And sometimes they'd give you a warning to say, we're going to reboot this machine, or or they give you a bit of advance warning that they had to shut down some part of their internal systems, but you'd get a little bit of warning, or sometimes they just go away. So we wanted our developers to flip their assumption from the assumption they were running on a reliable computer to the assumption they were running on an unreliable computer. And this is a big mind shift, and it's one of the biggest mind shifts that people have to go through in software engineering. And some people still sort of want to pretend that the computers will always be perfect, and you can ignore the fact that they might go down. And you kind of end up with these very expensive mainframe-style machines that have lots of redundancy built in. Some of the big machines we built at Sun were like that. But here we basically said, well, if any particular machine can die at any time, you want to be able to survive that. So what we'll do is during the day, between, let's say, 9 a.m. to 3 p.m., there will be a little service going around, this chaos monkey, and it will just delete machines in production. You delete them in test and production. So you had machines and they were just going to go away. And then you had to build a system that could deal with an individual machine going away. Now, this is, you no longer have one machine doing things. You have hundreds of machines doing the same thing. So losing one is losing, a few % of your capacity. And your system should be able to survive that.
Okay, so right. That's super interesting to me. But you said a whole bunch of really smart things all at once. You can't legislate against failure. You can't predict what will fail next. Compliance, all of a sudden, is not nearly as significant as we once thought it would. And the mindset shift, flipping the assumption from belief that the system is perfect to the belief that the system will fail, that's so interesting. How come?
I think it's because you start having to think at a higher level about building a resilient application. Like if you're in an environment that's full of danger, as opposed to an environment that's very safe, right? You behave differently. There was an example once, and you might have heard this before, putting airbags in cars made people drive more aggressively, right? And somebody said you should put a 6-inch steel spike in the middle of the steering wheel and everyone would drive much more safely. It's like a thought experiment, right? Right? You'd be terrified. You'd be driving really slowly and really carefully, right? So there's a sense that if you give people machines and you say they're going to work perfectly all the time, they write software which assumes everything's going to be perfect and it doesn't have good failure and error handling, and you don't get to think about, if I call this other service, is it going to work or is it going to not work? I'm going to assume it's going to work. And then when you're testing it, you're testing in an environment where most of the things work most of the time. So your error handling and failure management code paths and practices and processes are really untested. So the situation here is we were trying to introduce failures at a controlled rate so that we would have regular testing, and have an environment that was inherently dangerous. We were putting this spike in the middle of the steering wheel for the developers, effectively.
So the question is what did you guys learn out of all this?
What we learned was that in the sort of traditional software development environment, if developers have this notion that systems are perfect, then there's an operations team whose job is to make the machines look perfect, right? And the interface between those teams is that the developers are always saying, those stupid operations people, they always take too long and they have all these constraints that I don't like. And the operations people always say, well, the developers build these broken software that they throw over the wall and they walk away and it goes down, and they're sort of in conflict. You had John Olsbor on the show some point last year, and there's a whole DevOps world now where the developers and operations people work together to make it reliable. And the responsibility is shared much more across that boundary, and the teams are much more integrated. So developers are responsible for operations. So what we did was we put developers on call. We said, you're now the frontline support. If anything breaks in your system in production, we'll call you directly. We'll put you on the call. You're the frontline support. And they discovered that when you put them on call, they build systems that are very reliable. And if you don't put them on call, they build systems where they assume somebody else is going to fix it.
Well, that makes good sense. Right?
So,
we get it.
It's like systems thinking, right? You apply the pain to where it'll do the most good. And that was the basic idea. We did another thing, which is, you hear that maybe sometimes in the computing world you hear this term microservices now, where you take a large monolithic application that was written as one big bundle of code and you break it into lots of different pieces, where each piece does one thing. So now you've got an ensemble of small pieces that can be changed independently and they can fail independently. So if your software is one huge system and that system crashes, everything's gone. Right? If your system is hundreds of separate services and one service crashes, one part of your system maybe degrades slightly, and you can quite often work around it. So you get much more, you're setting up an architecture that creates much more partial failure. And then you typically have any one service, you have a set of, a developer or a few developers looking after that. So it's very clear what broke, and it's easier to figure out what broke, and you can call the developer that built it, or you can automatically fix it. And we've been building lots more automation around that.
And because the failures are small, you have more capacity to handle many more small failures as opposed to one giant catastrophic failure.
Yeah, exactly. You're basically building you're limiting the blast radius of a failure, right? It's lots of small isolated components with very clean interfaces. There are still some systemic failures that you can get, and those are dealt with at a higher level. So Netflix came up with a bunch of chaos monkeys, which they called the simian army because they had lots of different types of monkeys. They were sort of monkeying around with the system was the idea. So the chaos monkey just removed machines. It simulated a service disappearing, and the idea was that if you were trying to talk to that service when it disappeared, you could just retry somewhere else and it would succeed there. So you end up with a few retries when you kill a system, but there shouldn't be any state lost in that system. There shouldn't be any local information inside that system that would be lost. So that created an environment where all the state is replicated into multiple places, and if you lose any one place, you can still get it somewhere else, right?
So the system becomes stronger as it fails. Is that right?
Yeah.
So you get farther along. You get smarter about your system because your system has all these small failures. It's the anti-fragile deal.
Yeah. Yeah, when Taleb's anti-fragile book came out, I said, yes, that's the idea. The idea that if you work out, and physical examples are great here. So if you go and exercise a little bit and you hurt a little bit, but you get a little bit stronger and you're lifting weights, and over time you can lift more and more weights. That's great. But if you try and lift too much and you pull a muscle, then you can't touch anything for weeks as you fix your muscles up. So you've gone too far. But if you don't lift weights at all, then you need to move something. You can bust yourself just because in your daily life. So there's this idea that there's a certain amount of exercise that's good, too much is bad, and none is bad. So you want to have just enough that it makes you stronger. And a lot of the anti-fragile idea is around trying to figure out what is the right amount of exercise that makes something stronger, but doesn't cause it to break completely, but doesn't cause you to get sort of flabby and complacent. So that concept from Taleb's anti-fragile book is very applicable here. We're trying to apply a little bit of brokenness into the system just to prove that we haven't let any flabby practices and bad things creep in, and that we have good practices and we have good testing and people know what to do, and all of the systems around recovery and detection are all working properly.
So just enough failure to make sure your system is robust enough, but not too much failure so you would cause catastrophic failure. That is really a cool idea. Of course, the exercise metaphor is lost on me, but nonetheless, that is really an interesting journey. This intellectual quest you've been on for this new flip in assumptions, where's this change coming from? What's enlightened us? Why do we care, and why are we so interested in what's happening?
I think if you look back at what's the cost of failure, that's usually what's driving these things. So back when I worked for Sun, if we built a big machine and we shipped thousands of these big machines, and then there was a problem with the hardware, we'd have to do recalls, we'd have to do service updates. It's a really expensive thing to go fix. So we were really just paranoid that we would build something that might not work. We actually did have one or two times where we shipped stuff that was broken and had to do field recalls. So it was a real problem. If we look now, we find that computers are now, they're provisioned automatically by cloud vendors. If I want a computer now, I go to AWS and I say, give me a machine, and a few minutes later it's running. And I can have thousands of them. And they can break and I can replace them in a few minutes. So the problem of a machine breaking, it's inconvenient if one breaks a little bit, but it's not a big problem because I can get a new one. In fact, there's a system now, without getting into too much detail, but there's a new system now which will give you a machine in effectively, tens of milliseconds, and you can run it for less than a second and give it back. This is called serverless computing. It's kind of one of the new things that people are trying to figure out how to do. So basically getting computing absolutely on demand. But going back to how we got here, the problem right now is that if you're looking at a company like Netflix, the cost of being down is mostly in brand reputation, and it is very expensive for Netflix to have an outage. People will go and use another service, they'll go and find something else to watch, and the reputation is actually most of the impact. If you look at somebody like eBay, there is a real cost of going down because some of the sales just don't happen. Some of the things that were trades that would have happened don't happen. Some come back later, but you can actually lose money on these things. So I think what's happened is over the last decade or so, more and more of commerce has gone online, and the cost of failure has increased.
So this is amazing to me. Crazy.
Does that make sense? Yeah.
As more and more failure happens, organizations get smarter and smarter and less brittle. Where's this all going to take us? As more people start thinking in this new view, as they flip their assumptions, where's this all go for us?
So the first type of failures were pretty simple. We just wanted to simulate an individual one machine failing, right? But when we deployed the Netflix architecture, we'd broken it up so that we could deploy it into 3 what are called availability zones, but which you might think of as data centers or buildings. So everything this is the pattern that Netflix and other similar companies use. They deploy everything into 3 buildings at once in parallel, and the buildings are relatively close to each other. They're a mile or so apart. So what you're doing is you're saying, well, any of these buildings is on a different internet cable connection, fiber connection. It's on a different power. It's got different air conditioning. If a plane crashes into it, it only takes out one of these buildings. And the design then is you can run on 2 out of 3. And if you get a power cut, and this has happened a few times, something happens, bad weather, like Hurricane Irene took out, was Irene taken? Anyway, there were times where they would lose a building for some reason. And if you could run on any 2 out of the 3, then everything stays working. So that's the theory. But to test it, they built another monkey, a chaos gorilla, this time, because it was bigger chaos, which would take out a whole zone. So they run this in production about once a quarter, where they actually try to kill a third of their infrastructure in production to prove that the system will keep working.
Wow, that seems kind of risky.
It does, but then people have these disaster recovery data centers, right? That's a very common practice. In fact, it's normal. If you're a big company, you have a backup data center. And then you have to ask the question, how often do you fail over to it? Right? And some people, the people that are really good, maybe once a week they flipped from backup to the backup, or once a month, and then they flip back again, and they know that both sides work. But if I ask an audience in one of my talks, so who has a backup data center? They say, yep. So who actually has ever used it? They get lots of sheepish looks, and we don't want to take the hassle of using it, right? And it might break everything. Well, yeah, it does break things if you don't test it. So really, this is just the equivalent of continuously testing those backup data centers. So there's one more level. We had Chaos Gorilla, which takes out 1/3 of a region's infrastructure. They then have multi-region. So the data is stored on the east coast of the US, in Virginia, in Oregon on the west coast, and again in Europe. And all the data is stored in all 3 locations, which sounds wasteful, except they can actually shut down the east coast and run everybody out of the west coast or Europe. So this is a very symmetric model, where you're using low-cost infrastructure, you're replicating it 3 times per region and across 3 regions. So there's 9 entire copies of everything that's needed to run Netflix, and they basically need 2 out of 3 regionals or 2 out of 3 zones in a region to keep working.
Well, that seems kind of expensive, like super over-engineered. I mean, and that's a potential issue there.
Yeah.
Except that you're really not over-engineering it because you're using cheaper infrastructure but more of it. That's interesting.
There is some extra cost to it, but you can design out most of that cost by using low-cost components and avoiding a lot of the things you'd normally do in the data center that are very expensive. So they have a way of testing this, and of course we've gone monkey, we've gone gorilla, so the next one up is Kong, right? A really big gorilla. So the Chaos Kong exercise they do about once a month. In fact, I was talking to them last week. They actually had shut down the East Coast and sent all the traffic somewhere else. So they do that for a day or so. And what they're doing is they're proving there's nothing special about a zone, there's nothing special about a region. And every month or two, or every few months, they test this. So if some engineer develops a new thing and they make one of them and they put that in one zone or one region, then when the monkeys come along, they discover that. And so and everyone knows the monkeys are coming. So everyone, when they get to deploy, they deploy everything globally and symmetrically. And that means, and then they have this proof every few months that it is still symmetric and everything is set up that way.
Wow, that's just remarkable. It's so different. There's so much the community can learn from this. You've got lots to teach us.
So the community, so one of the things I did when I was at Netflix is I helped start and run the Netflix open source program. So we basically took the software we built to do all of this and we put it out as open source software, and other companies have adopted it to run their systems. So this isn't just a Netflix thing now, it's a Netflix open source platform that a lot of other companies do. One of them is Nike. If you think about the Nike Fuel Band and your Apple Watch and your sneakers recording you when you go for a run, there's millions of people around the world running around logging their data into Nike's online services. And they took the Netflix open source software and built out kind of almost complete copy of what Netflix had done to run that service over the last few years.
So what are the big learnings out of this? I mean, what are you sitting around in the evening thinking, wow, we're better at this because of this? What have you learned?
I think so what I'm finding now is that people are trying to adopt these patterns. They're trying to adopt cloud. They're trying to adopt some of these open source things. And they're still hanging on to the idea that they don't want to break things.
Yeah, right? I hear you.
You got to sort of be comfortable. You've got to, I mean, the whole point with this sort of new view of safety is to know that you're building a margin for safety.
Right.
But you don't know how big the margin is unless you test it. So you have to have a safe way to test how big your margin is, and do you still have that margin? And that's the critical sort of insight that's come along with all this.
And this flipping of assumptions, the belief that things will fail. I mean, it's not if they fail, it's when they fail. It seems so simple to us when we talk about it on the podcast, but I realize this is really a hard switch for people. This change is difficult for them to do.
Yeah, I'm seeing that. And when people set up new computer systems, one of the things I advise them is the first thing you put in is the Chaos Monkey, or the first service you should be running in a new environment. And then you install the rest of the application knowing that the monkey got there first. And people tend to kind of, when we're in production, we've got it all working, then we'll add the monkey. And of course, nobody then wants the monkey messing with their system.
I'm not sure anybody ever wants the monkey.
So you have to get it that way around. You have to build in the assumptions into the architecture of what is available and what is resilient and the activities that are going to be happening there. So that's kind of where we should be, right? There's a few other things they've been doing as well. Actually, this is mostly since I left Netflix about 2 years ago. They started building out a system for failure injection testing. So this is a system where, and the best analogy for this is like you drop a depth charge into the system and it goes deep in the system and then blows up somewhere very, very deep in. So one request going into the system is passed through and it's got a special header, it's a special tag that says, this one's going to blow up later, so you watch it. When you see this request come through the system, you track it, and you track it with lots of extra metrics and tracking information and logging information. When it gets to a particular target in the system, it causes that system to misbehave, to respond slowly or return an incorrect data or return an error. And then you watch how that effect ripples out from that point. So this is absolutely like laser targeting a particular system to see, okay, what happens if this machine fails once? And you can do it with a synthetic input where it's not even a real customer asking for real data. It's a synthetic test, but you're using these tests in production to prove that the things work. So you get that concept? So it's a very deep failure injection testing that's targeted into the system.
That strikes me as crazy brave. Like, you'd have to be so gutsy. It really makes you believe in your system.
So there's actually a paper on this. There's a guy called Colton Andrus who was working at Netflix at the time, and another guy from Berkeley University called Peter Alvaro who was working on testability and knowing what to test. And they got together and came up with a way to figure out which tests need to be run to prove the system's going to work. Like, where is it most likely to break? And which breakages are most likely to cause a problem? Because now you can point these injected tests in very, very targeted ways. You have to figure out what you're going to target. So I'll send you a link to that talk if people want to follow up. Yeah.
Oh, that sounds great. I'd love to have that. This is interesting to me. This is really a switch. This is bravely testing your systems. We're safe because we test.
I think so, yeah. And people are still finding their way into it. A few people have really got it, but it is still a thing that you still see it. When there are outages at infrastructure level and bad weather and whatever, you still see websites go down, even though these techniques have been available now for, we first started talking about them about 5 years ago. So it should be more prevalent now, but it takes a long time to get everyone's minds to shift over to a new way of thinking about failure.
It's amazing to me because it's a shift in thinking. It's a shift to the new view. I want to call it a cost argument, but it's not. This is a new view shift.
It's mindset, and the cost comes, the value of not going down for these, modern, there's a lot of software out there, right, that runs our lives now. I just saw a quote that said that there's more code in a John Deere tractor than was in the space shuttle, right? The things around us are full of software now, and they're full of services, and if those services fail, all kinds of bad things happen. So we've got to get better at building the software to be more resilient. And it doesn't mean we build individual pieces to be more resilient. We have to build systems that have margins in them so that when something fails because you did something bad to it or some hardware broke or you shipped a bug into it, that the whole system continues to work.
So what'd you think? Holy cow, I told you. Adrian Cockcroft. I can't tell you how much I appreciate him taking the time to have the podcast with us today. It was a really interesting conversation. The whole notion that you cannot legislate against failure. I mean, it makes total sense. We get it, right? But when you couple that with the fact that you also can't predict where the next failure is going to happen, so you can't make a rule that says don't fail, and you can't predict where the failure is going to happen, you've got to manage the margins. What you have to do is create controlled blast areas. I'm getting all these new words from the DevOps people that I think are excellent. I don't know if they work in safety, but it's an incredible conversation. I hope you liked it, and I hope you listened carefully. There was much in there. It's deep at a bunch of levels. In fact, the idea of chaos monkeys for fall protection, or chaos monkeys for confined space, or chaos monkeys for pilot fatigue, those are pretty interesting ways to test the margins of our systems and to really test the robustness and resilience that our systems carry with them, especially systems that are complex, many pieces tightly coupled, and that the cost of catastrophic failure is unacceptable, untenable. Pretty great conversation, I'd say. One of the greatest podcasts ever, but they're all pretty damn good. This one just kind of fits in with the rest of them. Thanks for your time. As always, thanks for subscribing. That makes a big difference. Tell your friends because more is better. Have some fun. Learn something new every single day. I bet you did today. And for goodness sakes, be safe.